Welcome back, and here is part 3 of my decomposing function videos. This one is a challenge problem. So hopefully you've gone through the first 2 parts and you've seen how we can take a given function and decompose it into 2 other functions that are just a composition of each other. So I want you to take a moment and look at the given function. So this is y equals the square root of sine to the power of 3 of x. And I want you to start asking yourself, how many functions do you see? Before we can do that, hopefully you remember from the part 2 video that I can rewrite the sine to the power of 3. So I'm going to do that. Alright, now let's look at this version of it. How many functions are you seeing here? Remember, the purpose of decomposing is to break it up into parts of another. Well, let's see. I know I can see the square root, so there's 1. Then I have something to the power of 3. Well, that's a second function. And then I have sine. That's a third function. So this particular problem is going to require 3 functions in order to decompose it. So let's start with the outer function. So what is the outermost function? Hopefully you see that it is something to the power hopefully you see it's a square root function. So let's call that one f of x. Now, we don't really have an innermost function because we have something to the power of 3. So let's call that the middle function. So the middle function is something to the power of 3. Okay, so let's give that a name. Let's call it g of x. So something to the power of 3, or we could think of it as just x cubed. Now this leaves the innermost function. So what function is all the way inside, or the smallest area in, or if you go into all these layers, hopefully you can see that it is the sine function. Let's give that a name of h. Okay. So if I decompose this given function using these 3 functions individually, what does this turn into? How can I rewrite this as a composition of other functions? So let's start with the outermost function. Well, the outermost function was the square root, which is the f of x function. That's what we called it. Then came the middle function, which was something cubed. Well, that was what we called g. And then we have the innermost function, which was sine, and we called that h. So this is the decomposition of that. That's how it would look in composition form. Now you're probably wondering, well, Stevenson, let's check this. This looks kind of weird. So when we do our checks with more than 2, we want to kind of break it down even further. So here's what I mean. So we're going to say f of g of h. So start with the innermost substitution, which in this case would be putting h here. So what is h? Sine. So g is going to be evaluated at sine. Okay, well, what does g tell us to do? Well, g says whatever you're evaluating g at, you're just going to cube it. So this turns into f of, so what is g evaluated at sine? It's sine to the power of 3. Or in other words, sine to the power of 3, just like that. Now we have f evaluated at sine of power of 3, or sine of the power of 3. So let's go to our f function. Well, f says whatever you're evaluating f by, just take the square root of it. Okay, so that means we need to take the square root of whatever f is evaluating. Well, f is evaluating sine to the power of 3. And notice, that was our original problem. So there you have it. It is possible to decompose a function in more than 2 layers. What it takes is just practice and training to train your eyes and your brain to see those possible combinations.